right, this set of notes, the first page will cover section 1.6 of the geometry textbook where we introduce polygons. Polygons are shapes that you guys have been working with for a long time, back when you're kids and you start learning what a triangle is and a square and a rectangle. So now that you're in geometry, we get a little more specific. So a polygon is defined as a plane figure, which just means it's going to be two-dimensional, sitting on like a sheet of paper like this. And there's kind of three main requirements. It has to be made with 3 or more straight sides, so no curves allowed. It must be closed, as in no gaps in the structure. And only 2 sides meet at a vertex. That one sounds kind of weird, but that just means if you put your pencil at any vertex, the vertex are the little pointy parts, the corners, you're never going to encounter more than 2 sides coming to those vertices. Okay, so let's go ahead. We'll call this a vertex, right? This is referred to as an angle on the polygon. All right, and that's just a side. And then just real quick for naming them, we need some letters at the vertices. So I'm gonna, maybe pick some letters that don't go in a natural order, like A, X, T, W, G. So when you name a polygon, you start at a vertex and you go around. Any order, any direction is fine, but you are supposed to go in order around the polygon. So we would call this figure. I'll just pick the W to start at. W, G, A, X, T. All right, polygons are either concave or convex. So concave means that one or more of the vertices rests in the interior of the figure, and it has one side that's caved in. So I always think it's easy to remember. You guys have probably visited this word before as well, but concave has the word cave in it. And that's kind of what this is, right? A cave. All right. A convex polygon, all the vertices rest on the exterior. No sides are caved in. So this one is convex. So some other things you can do if you're going to trace the lines, the sides, right? These sides always, if you extend them, they always stay outside the polygon. But on the concave one, if you extend the side of the cave, one of the sides of the cave, it extends to the interior. Okay, and another way to look at it is if you're going to draw arrows like this at all the vertices. Convex, these arrows are all pointing outside. But the concave one, you're going to have a problem when you get to this vertex, because to make your arrow, it's going to point to the inside of the polygon. All right, equilateral, lateral, that means sides. So it's a polygon with all sides congruent. All right, so the way we would see it, and you're going to have to mark your diagram, but right, you would see it with tick marks. This one is interesting. It looks like the angles are not congruent, so you can't have congruent sides without congruent angles. All right, equiangular, so that just has the word angle in it. So that's a polygon whose angles are all congruent to each other. So this one has been marked for us with arc marks and tick marks. As long as they all match, they are indicating that the sides are all, or the angles are all congruent. All right, this one is not marked, but I'm going to go ahead and square off those sides right there, or those angles. Okay, so if you put an equilateral figure and a regular figure together, what you get, or an equilateral and equiangular figure together, you get regular. And that's an important vocab word. You're going to see that a lot. And a lot of the stuff we do with polygons is with regular polygons, and they just sneak that word in often assuming that you know exactly what that means, but it tells you a lot of information about your picture. These ones are all completely marked for you, but notice that all the angles are marked congruent and the sides, right? Angles and sides. It's both equilateral and equiangular. All right, and there's nothing to write in this little line of information here, but these are all the vocabulary words that go with the polygons. And you will have to be able to use those to answer some of the questions. Okay, so for these examples right here in this first example, we just have to investigate these figures and determine whether or not it is an official a polygon or not. And then if it is, we're going to say if it's convex or concave. Oh, and classify it by its sides. We'll see what that means in a sec. Okay, so this polygon right here, or this shape right here, what we want to do is go up and look at those 3 bullets and decide if we can say yes to all 3 of those, and then it's a polygon. So does it have 3 or more straight sides? Definitely. Is it closed? Yes. And no matter where I put my pencil, do I only ever have 2 sides that meet at a vertex, right? And that I can say yes to that as well. So this is a yes, it is a polygon. This one is actually concave, right? Because if I did the little arrow thing here, I would be pointing to the inside. Each one of these is like a little cave. So this is concave. And so to classify it by its sides means we are going to name the figure that it is. So we need to know how many sides it has. So it looks like it has 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides is a nonagon. Okay, the next one, we'll just roll through our 3 little bullets. It is made with 3 or more sides, and they're all straight. It's closed, but bullet number 3, where it says only 2 sides meet at a vertex. If I put my pencil here, right, and I'm looking at the shape as a whole, I have more than 2 sides that meet at this vertex. Right, so my answer is no. And it's more than 2 sides meet at a vertex. All right, I go on to the next one. Is this composed of 3 or more straight sides? And you can say no from bullet number 1 because it's got a curved on it. Curved side. Okay, and then the last one looks like we're good for polygons. So it's got at least 3 straight sides. It's closed, and no matter which vertex I put my pencil at, there's only ever 2 sides that meet there. All right, so that's a yes. No caves on this one, so we call it convex. And let's see, it's got 1, 2, 3, 4, 5 sides. 5 sides is a pentagon. Whoops, I'm off my paper a little bit. There it is. Yes, convex and pentagon. Okay, example 2. We're going to classify it by the number of its sides and then tell whether it's equilateral, equiangular, or irregular. Okay, so this one looks like it has 1, 2, 3, 4, 5, 6 sides. So that makes it a hexagon. And the way it's marked and the way it looks is it's got congruent angles only. So that makes it equiangular. I'm going to write it above here. So it looks like an equiangular hexagon. All right, the next one has got 4 congruent sides. All right, so I mean, what we know right now is that anything with 4 congruent sides, oops, I pointed there now, it's not on my screen, but that's a quadrilateral. Okay, and if it's got the congruent sides, it's equilateral. Quadrilateral. And basically And quadrilaterals, a lot of them do have more specific names. So if you wanted to call it a rhombus, that's kind of its official name as well. We do that in chapter 8. We get more specific names for the quadrilaterals. But at this point, anything with 4 sides, we usually just call a quadrilateral. Okay, and then the last one, what I noticed is it's got 1, 2, 3, 4, 5 sides. That makes it a pentagon. And it's got all the sides are marked congruent and all the angles are marked congruent. So when it's both like that, we call it a regular pentagon. Okay, and then example 3, it says a regular hexagon has side lengths shown. What is the length of each side? All right, so there's that vocabulary word regular. So that tells us that this hexagon has all congruent sides and it has all congruent angles. And it's a very tiny hexagon too. So I guess the angles aren't really going to help us on this one, but the sides are going to help us. So even though they didn't give us all the sides, they gave us 2 sides. And we would know then that those 2 sides have to be equal to each other. So that's where this setup begins. Okay, we'll go ahead and solve. Okay, and then we're going to find the length of each side. So it doesn't matter which expression you go back and choose. They should both give you the same length. So if I choose the 4x plus 3 one, I'll plug the x in. So that would be 19 millimeters. And even though you didn't have to do it twice, I do sometimes just mentally plug the 4 into the other one, right? 5 times 4 would be 20. 20 minus 1 is 19. So I'm pretty sure that my math is right. Okay, so next we'll talk about area and perimeter of rectangles and triangles. And in chapter 11, we go quite in depth for area and perimeter of all the polygons. But triangles and rectangles are kind of some of the more basic shapes, and we do get some random questions throughout the year with this information. So we'll do a quick review of those formulas and what it means. So I am going to show a quick example coming up. Okay, so here is a rectangle and a triangle. And the nature of area, what it's asking is how much 2-dimensional space does that triangle or that rectangle on the triangle occupy? So it's a lot like laying a little gridded blanket down over things and then just counting squares. So I'm going to outline this rectangle. And if these squares were each 1 by 1 inch, then each square is considered 1 square inch. And what we could do very rudimentally, right, and this is what you do back in elementary school, is you just count squares. How many squares does it take to cover this rectangle? And sometimes I think we forget that concept, but that's what area is. So then when you learn the faster way to compute the area is to count how many squares you have going in this direction, which looks like 6, and how many that you have going in this vertical direction, 1, 2, 3, 4, right? So we know that this area is going to be 6 times 4, 24. So there's 24 little square inches. And the little abbreviation for square inches happens to be inches squared. Okay, so if we go down to our triangle, notice it is the same, it's got the same dimension across the bottom, and it's got this same width. And all we did was cut this rectangle in half diagonally. So even though we can't count squares so easily, we can take the area of the rectangle, which is 24, right? And divide that in half. So the area for this triangle would just be 12 square inches. Okay, and then last picture would be this triangle that we can't so easily just chop in half, but we want to recognize that it's still got the same base as the original rectangle, and because the little pointy vertex right here comes to the top, it's still got the same height. So we're still going to use this same concept. And we'll take the base times the height and then just divide that in half, because this triangle right here is still only half the area of the rectangle that has the exact same base and height. So this brings up an important rule when we use these formulas, and that is the base and the height are always supposed to meet at a right angle. So that's why we have to draw this extra line here. When we go back up to this one, right, the base and the height were at the corner of the rectangle, so we knew that that was a right angle. All right, so back to page 2 of the notes. The area formula for a rectangle. So here's our rectangle, and that theoretically has 4 squared off angles. And if we could mark our little squares across here, right, and then just count them up, that would be what our area is. And so when we do that, we take one dimension, usually we call it length, and the other dimension we call it width. So that's length times width. Usually you just see it without the dot. All right, perimeter, we didn't talk about perimeter on that other sheet, but perimeter is about the length, like if you were going to build a fence around this rectangle. Okay, so that is something that's called a linear measurement, because you could break that fence and stretch it out and make a line out of the perimeter if you wanted to. And so you just have to remember that you have 2 lengths and 2 widths. So I mean, you could just add up all the sides, right? And then the official formula that you see usually is 2L plus 2W, meaning 2 lengths plus 2 widths. Okay, the area formula for triangles. So we need a base and a height, and for some reason now the dimensions switch from lengths and widths to bases and heights. So this is a height, right, from the bottom up to the highest point that you can create, and then it meets at the right angle to the base. All right, so 2 ways we see this formula. You can do base times height divided by 2, right? Or the other way is to do 1/2 base times height. Either one is fine. And then the perimeter is just when you add up all the sides. So usually you'll see it like this, the sum of the sides. Or if you want to give the sides labels A, B, and C, you'll just add those 3 sides up. All right, so now we'll go ahead and compute the area. So we know we're just going to multiply the length and the width together. So length is 11, width is 9, and if you saw it the other way around, that would have been fine as well. So if I include the units here, when I multiply 11 by 9, I get 99. When I multiply meters by meters, I get meters squared, or square meters. So this is a large rectangle. If you could imagine a blanket with squares on it, and each square was 1 meter by 1 meter. That's how much area this blanket would occupy, or this rectangle. Okay, perimeter, where you just add up all the sides, or you can say, hey, there's 2 sides that are 11 meters each and 2 sides that are 9 meters. All right, so notice when you do this, you don't ever square your meters. They never get multiplied together. They just get added together. So that's linear. 40 meters for the perimeter. Okay, for the area of our triangle, we can choose which way to, which of the 2 formulas. I'm going to just go for the base times height divided by 2. Okay, so the base is 11 kilometers. The height is the one that is perpendicular to it, so 5.4 kilometers divided by 2. All right, so that's 59.4. Kilometers times kilometers, that's where you get your square units. So think about covering that triangle with a bunch of squares. All right, and that divides to 29.7 square kilometers. Okay, and our perimeter is simply to just add up all the sides. So we have 6 plus 8 plus 11. Okay. Alrighty. And that adds to 25 kilometers.